All right, welcome to the second half of the 9.2 notes. We're going to finish this section up with a couple terms. Here's a new term, actual yield. Right? And what actual yield is it is the amount of product that you acquired when you ran the reaction. A lot of books call it experimental yield. You'll hear me refer to it as experimental yield, but our textbook calls it the actual yield, and it is the amount that you gathered during an experiment. So it's the real thing that you can hold on to. And one thing about it is always going to be a number less than the theoretical yield. Okay? Which brings us to this other term, the theoretical yield. Okay? Everything we've been doing on paper, if we're doing it with a paper, pencil, and a calculator, that's what we would get in theory. In real life, there are a number of different reasons why the actual yield is less than the theoretical yield. If you just think about our experiments and you think about some of the accidents we've had, whether it's broken glassware, precipitate being left in a beaker, test tubes breaking, or just the inherent inaccuracy of the equipment that we have, you're never going to get what you would expect. Also, something that's a little more advanced, there are often side reactions that are occurring that is going to give us less than what we actually get. So calculating this is really straightforward. We take the actual yield and we divide it by the theoretical yield and we times it by 100. And this is a lot like how I calculate your grade. Here's the points you get, right? Divided by your total points possible, times it by 100, and that's how we calculate your grade. So let's look at an example problem. It's right here. In an experiment, we've got some PCl and some water reacted to produce 162 grams, okay, of HCl. The theoretical yield was 179. So we calculated it on paper, and we should have got 179 grams, right? However, we did the experiments, and we only got 162 grams. So that goes on top, times 100, you get a percent yield of 90.5. Now, if you ever forget which one to put on bottom, remember this thing. Okay? The big number goes on the bottom. Okay? So in other words, you never get greater than 100%. Okay? That's not going to ever happen. Okay? So big number goes on bottom. Well, let's try one. Okay, here we've got a situation where we've got 50 grams of product. That's the theoretical yield. But the actual yield is 49.9 grams. Okay? So let me just write out the little equation real fast. Okay? So the actual divided by the theoretical times 100. Okay? Equals our percent. Well, the actual in this case is 41.9 grams. Notice it is the smaller number of the two. Divided by 50.0 grams times 100. And when you get that, we get 83.8%. All right? Hopefully that makes sense. Now, that's the easiest way you're going to ever do a problem like this. You're not always going to be giving all the information. For example, look at this problem. Sometimes you'll be given the actual yield but not the theoretical yield. So, no problem. We can find theoretical yield because we've been doing that for a while and we're actually getting really good at it. So look at the values they give us here. If 8.87 grams of arsenic oxide is used in the reaction and 5.33 grams of arsenic is produced, what's the percent yield? Okay. Well, if you look at the way this is worded, it tells us that this many grams, 5.33, was produced. All right? That is the actual yield or the experimental yield. What we don't know is the theoretical yield. So we're sitting at a situation right here where, let me erase here, where the actual yield is going to be, let me try that again. The actual yield is 5.33 grams, okay, times 100. And what we don't know is we don't know this number right here. We don't know the theoretical yield, okay? But look at the information they gave us. Okay, so all we're going to do is do a problem that is grams of this to grams of that, like we've been doing. Now notice they don't give us an amount of carbon. So this is kind of nice. That means we don't have to worry about theoretical yield, and in fact the carbon is in excess. So, like we've been doing for many days, I'm going to go ahead and find out how many grams in theory of arsenic we should get. So, like always, first thing we do is change to moles. 197.84 grams. Okay. And 1 mole of arsenic. Oxide. Oops, sorry, my fault. Look at the equation. It's for every 2 moles of arsenic oxide, we're going to make 4 moles of arsenic. And then 1 mole of arsenic happens to weigh 74.92 grams. Okay? When you work that out, you get a value of 6.75 grams. That is the theoretical right there. So we'll stick that value right here. And notice it is smaller than this number, which is what we would expect. So when you work that out, you get a percent yield of 79.0%. Right? There you go. It turns out that we really don't need to do all that work if we're given some different information. We can find the actual yield if they give us the percent yield. So I'm going to write out the equation again, and we'll just do a little bit of algebra here. Okay, times 100 equals percent. All right. So let's see what they've given us. Well, right here they give us the percent. So I'm going to put in 62.1%. Okay. I'm going to leave in 100 because that's part of the equation. And then let's see what they want us to find. They want us to find what is the actual yield. Well, actual yield goes on top, so that value is going to be my x value. And then I need a theoretical amount. Well, what do they give us? Ooh, they give us the amount of carbon. Okay. Well, if I know grams of carbon, and I know this one must be in excess, then I can find grams of arsenic just like we've been doing. So let's go ahead and do that. Alright, so I've got 25.3 grams of carbon, right? 12.01 grams per 1 mole. The mole ratio is for every 3 moles of carbon at 4 moles of arsenic. And then 1 mole of arsenic weighs 74.92 grams. And when I work that out, that gives me 210.4 grams. Okay, so again, pencil and paper and a calculator, that's our theoretical. So I'm going to put that number right there, 210.4 grams. Okay, so now we're thankful that we have those algebra skills, and we're just going to solve for x, right? So the first thing I'm going to do is I'm going to take this one, I'm going to divide both sides there by 100, right? And that gives me x over 210.4 equals 0.621, right? And then I'm going to times both sides by 210.4, 0.4, and when I do that, I get 129 grams, and that is the actual yield. Okay, so there you go. Hopefully that makes sense. Algebra can be a great thing. Sometimes we could put it all together and you can do everything. And so in this equation, look what we have. We've got this compound. It reacts with ammonia and oxygen. It makes acrylonitrile, which is a fiber they use in plastics, and some water. we get to not only find who's limiting, we get to find out how much product, and we also want to calculate the percentage yield. And as a special bonus, a trifecta, so to speak, we've left this unbalanced. All right? So again, what I want you to do, and this is a challenge, if you can do this, you can do anything. Pause the video and try this problem. Do that now. Okay. Hopefully you worked it out. If you got an answer of 90.8%, pat yourself on the back. You did a great job. If you didn't, then just watch what I did and see where you, went wrong. Okay? First thing I got to do is I got to balance it. I'm going to put a 2 there. I'm going to put a 2 there. I'm going to put a 3 there. I'm going to put a 2 there. And a 6 there. If by some chance you didn't get the balancing part and you want me to walk you through that, just come see me. I'll do it for you. Okay? So I've got a balanced equation because we need those for all these. The next thing I got to do, I've got to find some grams of product. So I'm going to take my 850 grams of C3H6, and I know that 1 mole of that weighs 42.077 grams. Okay, the mole ratio is 2 moles to 2 moles. Okay, and then 1 mole of C3H3N, acrylonitrile, happens to weigh 53.064 grams. And that equals 1,071.9 grams. Okay, so there's that one. Let's do the ammonia. Got 300 grams of ammonia. Okay. 1 mole of ammonia happens to weigh 17.01 grams. My mole ratio is 2 moles of ammonia to 2 moles of C3H3N. Okay, and then 1 mole of acrylonitrile, C3H3N, happens to weigh 53.064 grams, and that produces 935.87 grams. Okay, so as you know, when we work these limiting reactant problems out this way, the compound that made the smallest amount of product is the limiting reactant. So ammonia here is my limiting reactant. All right? So knowing that, now I can do my percent yield problem. Okay? What is this again? Exactly, this is the theoretical yield. So I'm going to put my 850 grams on top. I got that from right up here. Okay? I'm going to put my 935.87 grams there. Oops, whoa, getting in conversion mode here, times 100, and then the percent I get is 90.8%. Now, if you can do that, you can do anything. So, again, like always, if you did not get these answers, if some of this stuff is still not making sense, please come see me, and I'll walk you through it. Hope this was an enjoyable and informative podcast. See you later.